Okay, I hear the recording in progress, so we will begin sharing the screen. All right, so we are over here. We are not going to have that long of a session today, actually. I should finish 10.1 fairly rapidly. Maybe I'll just sneak in some formulas from 10.2, but otherwise I wasn't going to start on 10.2 until next Monday, it looks like. Right now, tomorrow is a school holiday. In fact, I might as well just mark it off anyway. So tomorrow is so-called flex day. Teachers have meetings, but you don't have to show up. And Thursday, I'll reserve for questions and answers. And Friday's our next test. In fact, we'll be finished so early today, I think. If you want to ask me any questions about the exam, even today, you may, but you can wait until Thursday also. Okay, and you know the rules by now for exams, but I'll just repeat them again in case anybody doesn't quite get them. So I'll send the exam shortly after 8 o'clock or around 8 o'clock on Canvas announcements. You'll join the Zoom session. You must join the Zoom. I realize not all of you are here day by day. It's optional, but you have to show up on exams, as you know. You're responsible for 8.1 to 9.3. That's also the homework you submit. You must submit at least 70% of the homework. That's a joke again, because I do sometimes 70% or maybe a little bit less, but there's not that much for you to do. And you're gonna have one cheat sheet, one formula sheet. If you haven't already done so, put it together, front and back. Okay, put anything you want, sample problems, formulas, and so forth. And you're gonna have a calculator, but nothing else. So no other books, notes, people, calculators, internet, cell phones, and so on. Okay, then class ends at 9 o'clock. I'll close the Zoom session at 9 o'clock. And you have until 9:05 to take pictures, click, 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 click on your cell phone, or if you have a scanner, I prefer scanning because the quality is usually better. And then you have until 9:30 a.m. on Friday to submit the homework, although I'll accept it early. After class on Thursday, I'll start accepting the homework if you wish. Okay, so tomorrow's I call it a one-day weekend, so to speak, for us. Okay. And then after that, we only have 2 chapters left. Chapter 4 exam is on Friday the 29th. Then there's quote unquote only one more chapter, but it's a big chapter. It's our last chapter, chapter 11. Okay. All right, so I'll knock off some more problems from 10.1, sneak in a few formulas from 10.2 just to make things easier on me. And then that's pretty much about it. And then if you want to ask any questions, you can. Otherwise, we'll adjourn early. And no class tomorrow. Our next meeting is Thursday. And if you have any questions about the test, bring them in on Thursday. Okay. So we're back to doing this parametric equation stuff. So on page 640, mention this. X is given as a function of t. Y is a function of t. There's a third variable, sometimes called a parameter. And are X and Y related? Well, yes, because they're both related to t. Okay, so the most fundamental thing to do is to make a chart, t versus X, t versus Y. And then when you graph, just ignore the t and graph X versus Y as usual. Okay, but you can think of t as a passage of time. Sometimes you can eliminate the t, eliminate the parameter, and then you just have a regular Cartesian equation, meaning X and Y coordinates without the t. Okay. So I'll do a few more. Okay, problem 13. X equals sine of t, y equals cosecant of t. T lies between 0 and pi over 2. Okay. So can I eliminate the parameter? Well, since cosecant and sine are reciprocals, I can write y as 1 over the sine. And then I realize sine of t is just x. So y equals 1 over x. I recognize y equals 1 over x as a graph that looks like so, technically a hyperbola, but I don't have the entire graph. Let's see. I'm going from 0 to pi over 2. Now, what do I get if I plug in pi over 2? Sine of pi over 2 is 1. The reciprocal is 1. So I have an open circle at 1, 1. And then I think to myself, am I going that way or this way? Okay, t is not quite 0. If I actually plug in 0, then I get the sign of 0 is 0. So I don't quite reach it. So x is a little bit bigger than 0 on this hyperbola. And therefore, the reciprocal is a super big number. Okay, so the part of the graph that I have is right over here. Okay, so here's what it looks like. So here is the entire 1 over x. It's a hyperbola. We'll do more hyperbolas later. But the only part that we have goes like so. So starting way up here, coming down to an open circle like so. Okay, and then a side note, I made a little mini table here. So I'm very close to 1, 1, pi over 2, that's 90 degrees. So I had 89.9999 degrees. If you put it in a calculator, 89.999 degrees, you get x and y both very close to 1. Okay. Now, if you plug in 0.0001, which is a little bit bigger than 0 here, you get x is very small, whose reciprocal is very large. Okay, so that tells me it's going to go something like this. Okay, that's basically it. I haven't picked up my calculator that much this semester at all because you don't need to, but just for fun, let me show it to you. Let's see, 0.0001. So let me show you. I'm in the correct mode here. Let me switch back to radian mode. Okay, I'm in radian mode now. So sine of 0.0001. Okay. 9.99 times 10 to the minus 5. That's about 0.0001. It's very small. And therefore, its reciprocal is very big. There's a reciprocal of 10,000. So that point's over here. And then switching to degrees, 89.999 degrees. So let me change the mode to degree mode. Okay, so I switch to degrees. Sine of 89.999. It's 0.99999. It's practically 1. And therefore, its reciprocal is also about 1. Okay. All right, so that's it for that one. I'm going to show you 17. X is sinh t, y is cos t. And off to the side, I put y is greater than 0. But okay, depending on what teacher you had for Calc 1, you may not have had too much about sinh and cos. I did cover it in my Calc 1 class, and some of you had me, so you know that I did that. That was way back in 3.11. So let me show that to you in case you've never heard of that. Let me see if I can find it. I believe it was section 3.11. These are hyperbolic functions. The H stands for hyperbolic. Page 259, the hyperbolic functions. So notice it's a 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent, and you put an H at the end. So it's sinh, cos. The H stands for hyperbolic. I'm not sure how to pronounce that. It's hyperbolic tangent, hyperbolic cosecant, hyperbolic cosecant, hyperbolic cotangent. Okay, here's a definition of sinh. E to the x minus e to the negative x over 2. If you want to put that in your cheat sheet, you may. Here's a definition of cos. It's exactly the same thing as sinh, except instead of a minus here, it's a plus. E to the x plus e to the negative x all over 2. Okay, we need this for purposes of this problem. Right now, we have these two. And for derivatives, sinh and cos are derivatives of each other. Derivative of sinh is cos. Derivative of cos is sinh. So there's no negative here, like for trig. Derivative of cosine is negative sine, but for cos, derivative is sinh. And that kind of looks familiar, right? Derivative of hyperbolic tangent is hyperbolic secant squared. So All right, so that's what you need for problem 17. X is sinh, y is cos. And here are the definitions. So sinh of t equals, there should be an equal sign there, e to the t minus e to the negative t divided by 2. Cos is e to the t plus e to the negative t over 2. Well, can I come up with some kind of identity? Like in trig, we know sine squared plus cosine squared equals 1. So let me try sinh squared. If I square this, I get e to the 2t minus 2 plus e to the negative 2t all over 4. Okay. That's e to the t squared. This is e to the negative t squared. And there's the middle term, minus 2ab, 2 times a times b, but e to the t times e to the negative t is e to the 0, which is 1. Okay, so that gives me that. Similarly, cos squared is the same thing, except it's a plus 2. This thing squared is that. This thing squared is that. 2 squared is 4. But instead of it's a minus 2, it's a plus 2. 2ab, 2 times e to the t times e to the negative t. But e to the t times e to the negative t is 1, so it's plus 2. Okay, and you will notice that if I add these two together, I don't get 1. But if I subtract the correct way, if I do cos squared minus sinh squared, so this thing minus this thing, okay, cos squared minus sinh squared, e to the 2t's cancel out, e to the negative 2t's cancel out. I'm left with 2 minus a minus 2, 4, divided by 4, which is 1. Okay, so that was kind of weird. So bottom line, this new identity, cos squared of t minus sinh squared of t is equal to y squared minus x squared equals 1. Okay, if you want to put this in your cheat sheet, you may. Cos squared minus sinh squared is 1. Now remember for trig it was cosine squared plus sine squared is 1. But for the hyperbolic, cos squared t minus sinh squared t is 1. And since this was y squared, this is x squared, it comes out to be y squared minus x squared equals 1. Okay, that looks like a hyperbola. We'll do more hyperbolas later, but it goes like so and like so. But I crossed this branch out because y has to be greater than 0. If you look at the definition of cos, this thing can never be negative, right? E to t is positive, e to negative t is positive, positive plus positive is positive, positive divided by 2 is positive. I'm never going to get the negative. So I do not have this part here. Okay, then maybe just one last part. I've got the arrows going this way. See, how do I know that? I just plug in, let's say 0 and 1. So I make a little mini table. If t is 0, x is 0, y is 1. T is 0. Sinh x is sinh. So e to the 0 minus e to the negative 0. 1 minus 1 is 0, divided by 2 is 0. And the y coordinate is 1, cos of 0, e to the 0, 1, plus e to the negative 0, 1. 1 plus 1 is 2, divided by 2, 1. So 0, 1. And I plug in 1 for x. Okay, if I plug in 1 here, do you agree this is positive? E to the 1 minus e to the negative 1. E to the 1 is bigger than e to the negative 1. So when I subtract, it's positive. And if I divide it by 2, it's positive. All right, that tells me I'm going this way. So that's all I need to do for that one. Okay, then finally 19 and 21. Describe the motion of the particle whose position is given. All right, so I'm not going to do 19, I'm doing 19 star, but it's very similar. So this is the way it was in the previous edition of the text. X is 3 plus 2 cosine t, y equals 1 plus 2 sine t, t going between pi over 2 and 3 pi over 2. Okay, so this helps you a little bit for our real number 19. Okay, so in this one, I noticed there is a cosine t and a sine t. So I'm going to isolate cosine, I'm going to isolate sine, and then use the fact that cosine squared plus sine squared equals 1. Okay, so it's a simple algebra. Subtract 3, divide 2. Cosine t is that. Solve for sine t. Subtract 1, divide by 2. I get that. Now what I'm going to do is square this, add it to the square of this. X minus 3 over 2 squared plus y minus 1 over 2 squared. That's cosine squared t plus sine squared t is equal to 1. So that's how I eliminate the t. All right, and just multiply this out. So x minus 3 squared over 4 plus y minus 1 squared over 4 equals 1, or multiply both sides by 4. X minus 3 squared plus y minus 2 squared is equal to 4. And I recognize that's a circle, center at 3, 1, and a radius of 2. So the graph looks like this. Center at 3, 1, 1, 2, 3, 1, and a radius of 2. So I went 2 to the left, 2 to the right, 2 up, 2 down, and just go like that. But do I really have the whole circle? Probably not, because they told me to just go from pi over 2 to 3 pi over 2. So if I'm going from pi over 2 to 3 pi over 2, I'll just make a little mini table from pi over 2 to pi to 3 pi over 2. Okay, at pi over 2, I got 3, 3. So looking at pi over 2, cosine of pi over 2 is 0, so x is 3. Put pi over 2 here, sine of pi over 2 is 1, times 2 is 2, plus 1 is 3. So 3, 3. Plug in pi, it says 1, 1. Pi. Cosine of pi is -1, times 2 is -2, plus 3 is 1. And sine of pi is 0, plus 1 is 1. Okay, so 1, 1. And then 3 pi over 2 gives me 3, -1. 3 pi over 2, cosine of 3 pi over 2 is 0, plus 3 is 3. Sine of 3 pi over 2 is -1, times 2 is -2, plus 1 is -1. All right, so that tells me what's happening. I'm starting at 3, 3, then I'm going to 1, 1, then I'm going to 3, -1. Okay, so describe the motion. The motion is I'm on the circle, x minus 3 squared plus y minus 1 squared plus 4. Start at 3, 3, and then go counterclockwise this way to 3, -1. And that's a full description of how this particle moves. Okay. All right. All right, and let's see. Oh, that was 19 star. I ended up doing 19 after all. Sorry, I realized I. So, oh well, you get to practice one more problem. This is the real 19. And then after this, I'm done. I'll introduce some formulas from 10.2. But otherwise, I'll be done in maybe 5 minutes. So if you want to ask me questions, you may. Otherwise, we're going to end early. Okay, x is 5 plus 2 cosine pi t. Y is 3 plus 2 sine t. T going from 1 to 2. So whenever you get a problem like this, the first thing you want to do is isolate the sine and the cosine. So x minus 5 divided by 2 cosine pi t. Don't get freaked out by the pi t. If t is an angle, pi t is also an angle. Here, subtract 3, divide 2. Y minus 3 over 2 equals sine pi t. Then what I'm going to do is square this, and add them up. So x minus 5 over 2 squared plus y minus 3 over 2 squared is cosine squared pi t plus sine squared pi t, and that's equal to 1. So here's my equation. X minus 5 squared over 4 plus y minus 3 squared over 4 equals 1. Multiply both sides by 4. x minus 5 squared plus y minus 3 squared equals 4. That's a circle, center at 5, 3, 5, 3. Right, we change the sign of each of these. And the radius is the square root of 4, 2. So how do I graph it? Center, 1, 2, 3, 4, 5, 1, 2, 3. And then radius is 2. So I went 2 to the left, 2 to the right, 2 up, 2 down, and just kind of go like that. But it says describe the motion of the particle. Describe the motion of the particle as t varies in a given interval. All right, so we're going from 1 to 2 here. So I plug in 1. Plug in t equals 1. Cosine of pi is -1, so it's 5 minus 2, comma 3, t equals 1. Sine of pi is 0, so I have 3. So that's 3, 3. So I'm starting at 3, 3. I plugged in 1.5. I plug in 1.5, I'm taking the cosine of 3 pi. Cosine of 3 pi is the same as the cosine of pi, -1. So it's 5 minus 2. Oh, I'm sorry, let's see. 1.5. Oh, I'm sorry. Taking the cosine of 3 pi over 2, that's right. That's 0. That's 5. Plug in 1.5, that's sine of 3 pi over 2, that's -1. 3 minus 2 is 1. So 5 comma 1 is coming here. And plug in 2, I'm at 7, 3. Plug in 2, cosine of 2 pi, same as cosine of 0, that's 1, times 2 is 2, plus 5 is 7. And y is 3. If I plug in 2, sine of 2 pi is 0, so 3. Yeah. So here we go. So describe the motion of the particle along the circle x minus 5 squared plus y minus 3 squared is equal to 4, starting at 3, 3, and then going this way, which is counterclockwise, until you reach the point 7, 3. All right, and that is it, folks, for section 1. So schedule-wise, I think I'm right on par. So again, Thursday, I'm reserving the whole day for questions and answers, but if you don't have anything, I'll just go on to the next section, and Friday's the next test. Okay, let me just show you the formulas that you'll need for 10.2. Topic is calculus with parametric curves, page 649. So how do I take a derivative with stuff like this? Here we go. dy dx is equal to dy dt divided by dx dt, as long as dx dt is not equal to 0. Okay. This is a variation of the chain rule. If you look at the chain rule from Leibniz notation, dy dt is dy dx, dx dt. It kind of looks like you can cancel out the dx's, right? If I cancel this out, it looks like dy dt. If I divide both sides here by dx dt, I get this equation. So dy dx, and you can put this on your next cheat sheet. I would advise you not even to worry about it until after Friday's test. It kind of looks like if we cancel out the dt's, right? See the dt here and the dt here? Cancel them out, and it looks like dy dx. So dy dx is dy dt divided by dx dt. The next formula to put on your next cheat sheet, didn't even box it out, but here it is. It's on the bottom of 649. How do you find a second derivative of one of these guys? So using the Leibniz notation, d squared y over dx squared is d dx of dy dx, or the derivative of dy dx with respect to t divided by dx dt. Okay. And that's it for this. I'm getting a strange message that says your meeting will end in 10 minutes. So I'm not allowed to go past 10 minutes anyway. It's not close to 9 o'clock, but I should be done by then anyway. Okay, so that is a formula you want to put in your next cheat sheet. But if you don't want to do it now, that's okay. And yes, I see something in the chat. The only other formula you want in this section is on arc length, page 653. How do I do arc length in parametric equations? So one form of ds from section 1, in fact, that's going to be on the next test, was radical 1 plus dy dx squared dx. The other form was 1 plus dx dy squared dy. Okay. Well, it starts like so. Okay. ds squared is dx squared plus dy squared. Little change in arc length, Pythagorean theorem essentially. So ds is the square root of dx squared plus dy squared. If I divide inside by dt squared and outside by dt, that's 1. So here's the other version. dx dt squared plus dy dt squared dt, square root of the whole thing. Integral from alpha to beta. Okay, so that's how you find arc length in parametric equations. Okay, but I'll put that on hold. Let me check the chat. We square the equation to make it equal to 1. Okay, I think you mean that whenever you have sine and cosine involved. So problems like this one. Right, so immediately I see, oh, cosine and sine. Let me force this side to have cosine isolated. Let me have this sine isolated. That way I can force it to be, like you said, square this, cosine squared plus sine squared equals 1. Okay, so I think that's what you mean by the question. And something similar for problem number 21. But that 21 is a little bit easier than this. Okay. I think that's what you meant by that question. But I think I'm caught up now. Well, let me stop the share. I can see the chat easier. Otherwise, we'll finish. And I got a message that we have to finish in 7 minutes for some strange reason anyway. But that's fine. Okay, check the chat. I think I got the question in the chat. So yes, when you have cosine and sine involved, get to the point where you can get cosine squared plus sine squared equals 1. And yeah, mind you, that's not going to be on this Friday's test. It's going to be on test number 4. All right. So any questions, please? Otherwise, we're done for the day.
One last thing that I just want to check up that I heard correctly. You said earlier that the earliest we can turn in the homework was this Thursday.
Yes, after class on Thursday. I don't want it now. It's too early among all my other stuff. So I can gear up for it for that. So if you already finished the homework, that's great. Just wait until after class on Thursday for me to get that.
Thanks.
All right, you're welcome. Any other questions, please? All right, enjoy your one-day weekend tomorrow, and Thursday, I'll let you ask questions, and then Friday's a test. All right, have a good day, everybody.
Thank you.
You too. See ya.